Good morning. Thank you for joining the September 13th VOLTHA call. And today we have a discussion topic looking at cluster and HA design. This was sparked by some discussion on some of the juror tickets a week or so ago. And keep in mind, we do record these, so that keep that in mind when we're doing presentations and discussion. And with that, I think I'll hand it off to Sergio. Sergio, I will give you presentation rights.
Okay, let me just bring up my deck and then I'll I don't see anything that lets me share. Oh.
Julie, you go to screen.
Go ahead.
You go to screen, and then there's this ask, can I share your screen? If you go to that tab.
Oh, hang on.
Between.
Screen.
There you go.
Okay. So where do we want to start with this? Because there's a lot of places we can start. So can I guess, can I start by asking the question, where are the concerns, so that I can start digging through that first. Because we've presented this like 4 times already. So what I want to do is get to the root of the concerns, so we can stop presenting it and just continue on with the work.
Okay, and I'm not seeing, is there anyone from the Foundry on? I don't see anyone on the attendee list at the moment. So the discussion came up in the context of looking at Vol 1183, which was with some testing that they were doing at the Foundry with the Kubernetes cluster, and forcing a deletion of a vCore pod led to creation of another one on a different node of the cluster. OFAgent is out of sync and declares 0 device to ONOS. Bouncing OFAgent pod.
Okay. So let's go. Let me go. Okay, let me go to the OFAgent section then. Okay.
Just one note on that, Sergio, before you start on that one. Just to give an update on the issue that was raised on the by the Foundry a while back. It was pretty much having a cluster installed, but with only one single instance of core, one single instance of OFAgent, one single instance of everything. And what they noticed is after, I believe it was a couple of days, the VOLTHA core have migrated to another node, and suddenly the OFAgent lost track of that of where the core is, and it was kind of hanging there. And that was at that time there was a discussion about so is it supposed to move? It's supposed to stay together? So maybe we need to have an architecture discussion on how the OFAgent and the core should work. But in terms of that specific issue there, this is more about, it's an issue that Rich is looking at. But in the gist, it's an issue with pretty much with OFAgent that lost track after a while. The gRPC connection becomes stale, and then it doesn't recover from that. So it's not really an HA thing. This is more an OFAgent problem. So that said, I'll let you start, Sergio.
Okay, I missed most of that because my connection went dead for some reason. But that's okay, it's back. But I think I got the gist of what you said. They were running a single instance. So a single instance is not recommended for any kind of production environment. I need to make that clear. The whole HA strategy is based on the fact that you're running 2n+1 servers. and that the cores are distributed, primary and secondary cores are distributed across those servers such that the primary is not in the same server as the secondary. So I'll quickly show that first. So let's say your 2n plus 1 equals 3. Then what you would have is something that looks like this, where core 1 and its backup core are on different servers, then core 2 and its backup core are on different servers, and core 3 and its backup core are on different servers. So that way, if one server goes down, you still have at least one of each of the three different cores. So what I'm going to do to talk about specifically about OFAgent, since that was a concern, and how it binds to a specific core and therefore handles all objects that core is currently handling. I'm going to go through the Affinity router because that's the one in VOLTHA 2.0. The Affinity router is going to take care of assigning the OFAgents to different cores. So there will be 3 OFAgents if there are 3 cores. If we have more cores, and if 2n plus 1 is 5, for example, then we'd have a total of 10 cores, 5 primaries, 5 secondaries, running across all 5 of the servers. So, so at a high level, the Affinity router looks something like in a setup where you've got 3 servers. New audio hardware detected. No, I don't want to use any audio hardware. Okay. So what I've got is 3 cores, 3 primaries, 3 secondaries, set up across different servers, as I showed in the previous diagram. And there's a OFAgent Affinity router basically there's 2 Affinity states that are maintained within the Affinity router. One is for the OFAgents, and one is for the devices. The devices and the cores. So what device is currently being handled by what core. So northbound, you'll have 2 different gRPC APIs. There's a streaming gRPC API that's presented on a specific port, which I've not yet decided, and the standard gRPC API that supports everything but OFAgent. So all other calls, the CLI, the REST API, everything else will come in through the standard gRPC API, and in fact, Envoy is in the middle of all that. The Affinity router also has a control interface, and that control interface is used to used to inform it of different events, and I'll go through one of the events just to give you an example here. So the way this works, I actually have gRPC broken out quite nicely here. Sorry, OFAgent broken out quite nicely here. So
you're fading,
Sergio.
You're fading.
Remember your directional mic.
Oh, did I switch to my directional mic? Ah, crap.
Well, you faded, and so I'm assuming it's your directional mic issue.
Yeah, it's because my computer switched it. It said, "Oh, you have new hardware," and it switched me to the directional mic. Can you guys hear me better now?
Yes.
Yeah.
Oh yeah.
Okay.
Get a Mac.
No, I just switched to my other mic, and it works great. It's the one on my webcam, so that one works great. Okay, so the initial binding. So what happens as OFAgents connect to the through the Affinity router? What's going to happen is that they will be assigned to a core pair, primary and secondary, by the Affinity router, and that assignment is random. It doesn't really need to be fixed. And the reason I say that is because as soon as the OFAgent is bound to a core, so as soon as it connects to the Affinity router, a core will be picked, a table will be built, like the one that you see there on the right. So OFAgent 1 will be bound to core pair 2, OFAgent 2 will be bound to core pair 3, and OFAgent 3 will be bound to core pair 1. And that's permanent until something happens. If a server goes down, it doesn't matter, because one of the 2 instances of any one of those pairs will remain. In one case, both will remain. In 2 cases, at least one will remain. So a server going down won't break that binding. So the only thing that can really break the binding is if the OFAgent crashes or goes down and a new one gets respawned. And it's very simple, because if you look at the next chart here, if an OFAgent goes down, then what happens is that
what do you mean by what do you mean by server goes down? Is there some kind of keep alive that's running to detect that it's been lost?
No, if a server, so based on the diagram I showed earlier, the cores, the primary and the secondary of every core, right, of every core pair, are on separate servers. So if one server goes down, you will lose at most either a primary or a secondary of one of the two core pairs. And the third
I mean, what do you mean by when you say it goes down? I mean, how is that detected, I guess, or how is that propagated?
It doesn't matter. It doesn't matter. That's the Affinity router will detect that the core, the primary or secondary, has disappeared, and will use the other one exclusively. So basically, the connection to the core is lost. It can't reach it, and so it'll just use the other one, right? So there doesn't really need to be an event. The loss of connectivity is enough to let the Affinity router know that it can no longer talk to one of the two in the pair, and it will use the other one exclusively. Okay, is that clear?
I think so. So like a TCP timeout,
yeah.
or
yeah, it's like a TCP timeout. Okay. Yeah, exactly. And in fact, it'll be set to be very short. The other option, which is very, very easy to implement, but I don't think is necessary. It just adds complexity to the code. Is to notify through Kubernetes, through the Kubernetes API, notify the Affinity router that a server's gone offline, and then it can figure out which cores are no longer accessible, and not even bother with them. But initially, I don't think that's necessary. Some testing will confirm that for me. So for now, the intent is to say there's a timeout. I can no longer reach that core. I assume it's gone. I'll use its backup or the primary, depending on which of the two disappeared, right? Because it sends everything to both. Under normal operating conditions, both cores get every message, and they disambiguate the message based on a serial number in the request. So let's say a OFAgent goes down. So connectivity is lost. Again, it's streaming gRPC, so that one for sure. The minute the agent goes away, the stream is broken, and what's going to end up happening is that entry will be taken out of the binding table. So when it comes back, so we come back over here, we say, okay, when the OFAgent comes back, the Affinity router is going to assign it to the first free core, which happens to be the core that the other OFAgent was assigned to. So there'll be no, what core should I assign it to? There's only one hole in the table. And so that OFAgent will inherit all the devices that were on that core and start reporting them back into ONOS. So overall, and if two go down, the same thing happens, right? There's two free slots in the table. One of them is still remains bound when the two new instances are brought up by Kubernetes. They connect, and then they get randomly assigned to the open slots and to the cores, and they basically query all the devices and then report that back up into ONOS, and there's no duplication or no overlap. So that's the way the OFAgent would restart and reconnect with its cores. It always goes to the single entry point, which is on the Affinity router, and then it decides how to bind the OFAgents to the cores. Is that clear?
So how is this different from the 1.x implementation? I mean, I know that the bits and pieces are different, but how is the connectivity loss detection?
1.x, in 1.x, the OFAgent would try to connect to each core one after the other, and it would just stumble on one that didn't have an OFAgent assigned to it, and it would get connected. Whereas the OFAgents are actually connected through the router connected to two cores. So even if one dies, it's still got connectivity to the other one. So if one dies either because a server goes down or because it crashed, right? The core itself crashed without a server outage. There's still another one available. So it basically gives you virtually 100% availability on the cores, which you didn't get before in 1.0. The OFAgents would just look for a core and bind to it. And as they started, they just go and end up binding to whatever core didn't have an OFAgent bound to it yet. Whereas this way, the Affinity router binds them to the cores and actually manages the primary backup relationship and all that other stuff to make sure that there's always somebody to talk to.
And just to add to what Sergio said as well, in 1.x, when a core dies, that OFAgent commits suicide, kills itself, and respawn. And the reason why it does that, because it may be connected to another core that has a different set of logical devices for it to connect to owners. So in this new design, it doesn't need to do that.
But for the Foundry's case, right? So since they only have one instance, they have a 3 server using the Kubernetes, moving things around. But I believe the OFAgent and owners and the VOLTHA just one instance, right? So how does it? So does it mean they spin up another VOLTHA and the OFAgent stay on the old server or something like that?
No,
I don't know.
So first of all, there should never be a single instance of anything running. That's not the recommended configuration. So I mean, it's a good configuration for developer testing, but it's not a configuration that you'd be using in production.
Yeah, I think one of the other reasons is the OpenOLT adapter right now. I don't believe is still it's still a single mode, right? It doesn't support HA. So when the adapter doesn't support HA, and the core, I guess when an adapter. Sorry.
So here's my question though, Sean. So the OpenOLT adapter doesn't support HA yet. So are we going to support a corner case when by 2.0 everybody should support HA? Like the question is,
yes, that is the requirement, right? That's a requirement, right? So okay. No, I just wonder how does the case happen? Is the OFAgent is on one server and then Nick, is that correct that your OFAgents stay on one server and then the cores go into a different server?
Not by virtue of any explicit action, by virtue of Kubernetes deciding arbitrarily which pod to put where. Sometimes it's the same, sometimes it's different, and it's not by any explicit configuration on anybody's part. It just happens. It's just kind of default where Kubernetes decides to put pods based on capacity, based on CPU, based on time, whatever it decides. There's no stable set any of that today that keeps it together.
But even if it's on different servers, the OFAgent should be able to find the core by virtue of DNS anyway and connect to it.
Yeah, which is the same way as it. Same way as DNS finding your way to the right pod. It's just the idea, I guess, now that there'll be more of them.
I think the problem today is that it's doing DNS at boot and then store it as an IP. So basically, the DNS entry expires because the new core is coming up, and there is like a timing thing.
Right.
And if timing's not right, the OFAgent doesn't go into reaching to the V core.
It doesn't do a lookup again to find the new IP.
It doesn't re-look up to find the new IP.
Okay, I understand. So
there is a timing thing currently.
Yeah.
Yeah.
Okay, I understand. So the OFAgent stays up, and it just doesn't re-query DNS to get the new IP address.
No, the thing is, both vCore, we killed vCore, and then OFAgent commits suicide as expected. But then when they restart, there's a race condition depending who starts first. And if OFAgent starts first, he gets the old vCore IP. Yeah. And then the vCore gets the new IP, and then they're out of sync, and vCore cannot connect anymore.
Okay, that smells like a Kubernetes issue to me, or a DNS issue to me. But anyway, there's a simple solution to that. Have the OFAgent wait for a period of time before it commits suicide and restarts, just to give the system enough time. And the only question is, how much is long enough before it does that?
Or maybe just asking DNS every time it needs to talk to the vCore, because I think it's just doing once at boot. I mean, startup.
Yeah, a retry logic that says, "Oh, I couldn't connect. Okay,
try again.
Yeah.
Try again, or recommit suicide and restart. Right? Just keep restarting until you can get a connection.
Yeah, it's only the retry, logic that is not well there. It's not well done. So that has to be done to work, but it's not an HA issue per se.
No. So in this case, the OFAgent should never need to commit suicide unless you lose 2 servers, and that's a double fault, and it's not supported in any HA configuration. You know, we support a single fault, which means 1 server going down. We're not going to support 2 servers going down because that's a double fault. Okay. So are there any other questions on this? Does this make sense to everyone? Because this wasn't in the original deck. So this was something we hadn't presented before. Because the details behind the Affinity router hadn't been nailed down yet, but it's getting pretty solid now in terms of what it needs to have and how it needs to look. So are there any other questions on this piece here? Ken's going to go over some flow diagrams and state diagrams as well, to show what happens under different conditions.
So back to that the juror ticket, right? So is there anything? It seems like there are some. I heard there's some resolution on the table.
Oh yeah, it's just the retry. The retry needs to be beefed up to check to request.
So this is Rich. There is a bug in OFAgent. Right. Actually, there may be 2 of them. I'm looking at it right now, and I understand what the problem is. So I don't believe there's an architectural issue here. There's a bug.
Yeah.
But do you think after the bug is fixed, we don't need to do the retry, that kind of the mechanism, or it's still good?
The bug is in the retry mechanism, right? Or at least one of the bugs.
The bug is in it actually freezes. So OFAgent fails to kill itself. So it's basically hung. If you kill the OFAgent manually, everything comes back. And for me, I found it very difficult to reproduce this problem. I could be on the computer for 6 hours and see this happen once. So it's been very slow going.
But you know how to fix it now, right, Rich?
Yes, I have found one bug. I have fixed that. There's still another bug, and I know that because it took me 6 hours to find where it freezes again. I have an idea of where that is, and I'm testing that today.
Okay.
So would that be applied to both 1.x releases and then also to does the bug require on both branch, right?
Yeah, we might as well fix it in both. I mean, it doesn't make any sense to not fix it and leave it there.
Okay. Nick, do you guys have any questions?
No, I think Richard seemed to have the solution, or the pass-through solution. We're just ready to test it when.
But again, right? So for the deployment scenario, or we're going to have, are we going to still have one single instance on 3 servers, or we're going to build 3 instances out of VOLTHA now? Each one has 1 instance.
Well, assuming we're going with what exists right now today, we have 3 servers, and there's 1 vCore, 1 OFAgent, 1 Envoy, and if we happen to lose a host that pod is on, then Kubernetes will restart that pod on another host in its time. You know, sometimes that takes a little longer than we'd like, but That's what exists today.
But you can.
I mean, you.
Yeah, it's not HA, right? It'll restart. It takes whatever time it takes to restart. It's not HA. You have to wait for it to come back and
right.
all be up and running.
So there's a timeout in Kubernetes that, and I've adjusted it somewhere. I can't remember what it is. That basically says how long to wait around before you realize a host is gone, a node is gone, and its pods are gone. And the timeout there is arguably pretty long. I believe I read the rationale was that somebody wanted to do upgrades. They wanted to give it enough time to be able to finish, things like that. But I mean, it ended up being something like 5 to 10 minutes, something.
Yeah, I remember that, 5 minutes.
So so the workaround now was if you shorten that timeout, there's some configuration you can do to shorten that timeout. Kubernetes realizes the node is gone, and pods on that node is gone, and he'll restart them someplace else. Generally speaking, that's, okay. It's not HA, but it's okay. It's just we run into this issue where OFAgent and vCore get in a mismatch of who's on first, and we might have to go back after the fact and kill OFAgent to get it to reconnect again. That's been the only issue.
But that's as a result of the bug that Rich was talking about, I guess.
Yeah,
right?
yeah. That's the thing. So it could be better, but that's the case.
Yeah, once this bug is fixed, it is not fully HA, but it's redundant.
It has some level of tolerance.
Self-recoverable, I guess.
Right.
Yeah.
So if the expectation it's redundant, it's not highly available, right? Then I think longer timeouts should be acceptable. And the danger of reducing the timeouts is you get into other race conditions that now it thinks something's wrong when it's not, right? So, but it also sounds like there was another fail-safe that was discussed about potentially having OFAgent restart if it can't reconnect right away. Is that something that's worth adding as well?
Yeah, so I was curious because I want to say the Envoy, the web pod, doesn't have this issue, and it is pretty aggressive about killing itself off really quickly if vCore's not around. And I guess I'm curious between the difference in the logic that exists there versus an OFAgent. I haven't looked at it, but it seems like the VOLTHA or the Envoy container takes care of itself much more quickly.
Well, the Envoy container has an envoy-d running that's actually feeding it new configurations. So what happens is envoy-d is monitoring how many VOLTHA cores are up through the KV store and waiting for an event. So if a VOLTHA core disappears, that event will hit envoy-d. Envoy-d will rewrite envoy's configuration to disk and then respawn envoy with the new epoch number. So the new envoy will start to take over the connections of the old envoy over time, and eventually when it's taken over all the connections, then the old envoy dies and the new envoy has all the connections. So it's got completely seamless transition from one to the other. But the reason it's so fast is because it's monitoring a KV store that actually reacts pretty quickly to the disappearance of a core. And so when the key for that core goes away, it will reread the information on the remaining cores, their IP addresses, and the information it needs to build the configuration to then respawn envoy. Does that make sense?
Yeah, it does. I haven't looked at that code, so I'm not quite sure, but I mean, yeah, it makes sense.
Okay.
And also the OFAgent, just to add to what you said, the OFAgent does a poll, a regular poll onto the VOLTHA core to get the list of logical devices. And it's during that one poll that when it doesn't get the devices, the list or each time out, it will have a set of retries and everything. So that adds to the time compared to the mechanism via the KV store, which is much faster.
One question is, with this HA mechanism or scenario, I mean the design here, will we bring the same thing into the NAM an ONOS HA mechanism, and potentially the northbound interface toward the if we're going to have awesome adapter somewhere above the NEM site, it has the communication of the mechanism for the VOLTHA HA being established toward the NEM and ONOS site.
So ONOS has its own HA mechanism and can be clustered, right? And it works. You know, VOLTHA doesn't see that and doesn't care. The OFAgents will connect to ONOS the same way they do today, I believe. David can correct me if I'm wrong, but I believe that the northbounds should see no difference between a clustered ONOS or a single instance. And then the NEM shouldn't really care, right? I mean, it's communicating southbound through a proxy, and that's all it sees. The whole HA story is hidden below the proxy and the Affinity router, and nobody northbound even knows that that's there.
So is the Affinity router also apply on the NEM side, or
the NEM will
independent. That's the point.
Yes. If the NEM sends a command to VOLTHA using the REST API, the Affinity router will take care of routing that request correctly, so it hits the core that's holding the device in question.
Oh, okay.
Sean, are you talking more about a HA interface above CIBA as opposed to below CIBA? I mean, I don't know that they're talking about from CIBA to VOLTHA. I think they're talking more from an external interface into CIBA.
Both. You know, so what I'm saying, within the CIBA, you know, there are multiple interfaces, right? I mean, so what are the? But okay, so the Affinity router is part of the VOLTHA architecture. So whatever northbound coming down to the VOLTHA, the Infinity router within the VOLTHA core cluster will handle that. Okay, I got that one.
It'll handle it for all write and for all write requests. Read requests are sent to a read-only core, right? And the Affinity router has nothing to do with that. It actually goes straight from Envoy to the read-only core. But that's just a detail. Okay. Sorry, continue.
No, but the northbound, like Mike was saying, so northbound of the NEM, the potentially so we're building a app. I'm sorry, I'm going to bring some of the CIBA project into this. If we're building a abstract OLT, would there be also HA cluster mechanism need to be in place? Matt, do you know about that part? That will be north of the NEM, right?
What was the question? I'm sorry.
Abstract OLT.
So right now,
Don's here. What's the question?
Oh, okay, Don. Oh, you got released. Okay. Yeah. So the abstract OLT would does this require HA also?
Out of prison.
It's not HA right now.
No, it's not. I mean, I imagine what it would be similar to, I mean, anything else, right? At some point, we might start a stateful set of 3, and you put an Nginx or whatever load balancer in front of it, and make sure that
you wouldn't even need a load balancer, because any abstract OLT needs to know kind of the state of being for the abstract chassis.
Right.
So you would just have to share that. We do have a serialize it to JSON to disk, so that you could restart it and you wouldn't have to rebuild the cluster. Right?
But I mean, the idea would be is that each service at that layer would start its, let's call it a stateful set, call it whatever, and then have something, you know, maybe it's just a regular Kubernetes Nginx load balance instance or Affinity or whatever, just something that says, no matter if there's 2 or 200 of these instances of abstract OLT, there's the one front door that's always there.
Yeah, I mean, I'll be honest with you. I don't know that this would be a real good candidate for HA. I don't know if it would be worth the effort, because it's not in the, you know, minute-to-minute operation of the cluster. It's just for configuration.
Okay.
As long as it can recover its state. Does that make sense? as long as it can rebuild the associations between OLT chassis and abstract line cards.
Right. I think the bigger point is as long as every layer, like so VOLTHA to ONOS, as long as the representation to ONOS' point of view that there's always going to be either one or however many OFAgents and vCores there to talk to, he's taking care of his redundancy. And then from the ONOS point of view, if there's 3 of them, as long as there's the one, entry point into the API to add stuff into the OLT, so that one representation that's supposed to always be there has been presented north to SIBA so that the synchronizers and XOS can say, I'm going to go get to vCore DNS name, and then something is always going to be there to answer that. So each side can scale itself however it needs or deal with its HA however it makes sense, whether if it's to the second or if it's a couple minutes of a pod restart. But but we shouldn't have everyone's HA dictate the next levels up HA.
No. My only concern, and I mean we'll just have to see how to address it, is the XOS Tosca interface. And if it moves IPs, I have no way of knowing where that is. So I'll have to probably use DNS.
Yeah, I mean,
you can use a floating IP, right? You can use a floating IP so that if it moves,
Yes. Yeah, and that's so we'll have to solve for that.
But I mean, it's
the same thing with doing a new DNS lookup to see if it's changed.
Isn't the Tosca engine isn't behind a Kubernetes service IP?
I think it is. I think it is. That's what I'm saying. It's all
a
of the
public IP or a routable IP.
The Kubernetes service, right? All of the stuff that we enter into is a Kubernetes service, whether it's a node port or a cluster IP. We go back and forth, but the whole point is as long as you stick with using the Kubernetes service way of finding where you're trying to go, which is typically a DNS name, whether it's a server record lookup or whatever, that's your entry point, right? It's just the answer you get to that DNS may change depending on the state of the cluster, right? If I ask right now and I get one, 10 seconds later it dies, I need another one, I need to do another lookup.
Yeah, I haven't looked at it.
Sure. We haven't. I mean, the other way of doing it is like the server record style, which says you ask and you get the 3 or the 4 or the 10, and then you have the intelligence on your side to cycle through them and pick the one that's working.
Right. So I would think that you're not dependent on the IP of the Tosca server. Kubernetes is going to essentially abstract that away from you.
Right. I'm the only one coding it, and it's just not been on the top of my stack.
Yeah.
Yep. No worries.
But I think the catch that I think maybe we keep running into is we are depending on these names. It's just if the name, if you have to reconnect, you can't assume that the name you looked up earlier is any good now. Either
resolution.
Either you need to look it up again, or the service that's being advertised has to provide a list, and then you work the list.
Yeah, I mean, you could even have a daemon that wakes up every minute and checks to see if the IP has changed. Because it could have, between provisioning events, that IP, if we had some issues on the cluster or did upgrades, that IP could have changed 2 or 3 times before I actually need to open up a WebSocket to it again.
Okay, Sergio, do you have additional? You mentioned something about the flow and.
So Ken's going to go over some sequence diagrams. So Ken, are they all in this deck, or do you want to share your own?
No, they are not. Well, the gist of it is in the deck, but there's some updates.
Oh, that's right. You're on the web. Right. Okay.
Yeah.
Okay, so you can steal the sharing away from me and hand it to Ken then.
So just a quick question. So I guess probably with regards to say the Envoy implementation of high availability. So did you guys notice any issues with loading? Once you started loading up the system, were there any false triggers for cores going away or anything like that you saw, or basically this is independent of loading of the system?
So Stefan did a lot of testing on system loading with very small VMs to see where things started falling apart with both etcd and with console as the KV store. There was a whole report out on that you can look at that shows when things start to fall apart based on memory and CPU utilization. Again, for small VMs, right? He downsized all the VMs in order to hit the limits pretty quickly, right? And used simulated OLTs and other such test mechanisms to load it down. But in my testing, prior to right around the POC3 timeframe, I guess it was, we had we were loading the system down, and there were no false triggers that I could see. I mean, when a trigger happened, well, sorry, I'm going to correct that. Due to issues with console, or the way we use console, we still haven't bottomed that out completely. Sometimes the Envoy would actually restart because it thought there were only 2 cores left, and when indeed there were 3 cores, and console was all screwed up and was providing bogus information back to Envoy D, and it would restart Envoy minus 1 core. But that was related specifically to the KV store that we were using or misusing, because we're really not entirely sure if it was because we were misusing it or what that was causing issues. But other than that, if the KV store is providing the right events and the right information, then things work without an issue from the testing I've done.
Right. So is it better to use that mechanism to detect the core going away rather than relying on, say, TCP timeouts and retries? In the case where things are loaded, or
it's much faster. It's so much faster to use the KV store to detect the core going away. There are other things like periodic polling that could be used, right? I mean, I can look at all those things, right? It's just that periodic polling is going to, how big is the period? If you say, well, I'm going to poll every core 10 times a second.
That's the problem, right? Yeah. I mean, depending on the loading, it may work in one situation versus another. I'm just wondering if we could say one was more reliable versus the other, or both more insensitive to loading, I guess.
So the thing is, if your data from your KV store is wrong and the core is still up, one option is to say, well, let's do a poll after I get the information that the core is gone to see if it's really gone. But how many checks do you need to make on the checks before you say, okay, I've checked enough and I know the core is really down? It's sort of a trade-off.
Right, and I guess will it recover if it makes that false choice? I mean, let's say it gets bad information and decides that the core's gone. Will things recover? I'm talking about the 2.0, 2.x model.
Oh, in 2.x, there we should have it to the point where the KV store isn't providing bogus information. We understand it well enough, and we're not going to get bogus information out of the KV store. The only solution when we started getting bogus information from console was that we had to restart the console cluster completely in 1.3 or earlier. I don't think we're going to see the same problem with etcd, but until we've really loaded it down and tested it thoroughly, I can't vouch for that.
Sure.
Well, in 1.x, we had a separate service. It was embedded within the core, which was called the coordinating service. That's the one that was writing the core information inside the KV store. In 2.0, we went away from the coordinator, so we don't have that coordinator service. So we're not relying on the etcd to figure out where the cores are. We're just using Kubernetes for that.
Okay, I guess we'll wait for the testing, I guess. Hopefully everything will just work out.
Okay.
You should have, oh, go ahead. Sorry, Sergio.
No, I was going to say, okay, so should we hand this off to Ken? Oh, there we go. I just saw it. Okay.
Thanks, Sergio.
Thank you.
Okay, can everyone see my desktop? I was talking to myself. I was on mute.
Yeah, I can see it.
Okay, is it clear enough, or is it should I zoom in?
Looks good to me.
Okay, so most of the diagrams that I'm going to show is pretty much we have shown most of them, but maybe there's some slight modifications. But the gist of it is pretty much the same as before. And here I'm showing, and the focus on those diagrams is really the interaction between the core and the adapters. So here's an example of a startup. Like all the cores are coming up, all the adapters are coming up, and Kafka has come up first because we need Kafka up first for everybody to be in sync. So in the startup scenarios, what we'll have the core. In this case, I'm just showing only one because the diagram for multiple cores get more complicated. In the case of core, and they all follow the same pattern. So a core comes up. The first thing that it does, it creates two set of topics on the Kafka. One I call a group topic called /core. This is to receive broadcast information. For example, if an adapter wants to send information to the core and does not know which core to send it to, it will just broadcast it under the /core topic. And then it will also create a topic for its own. In this case, I call it core/core1. That could be instance ID, can be anything. So we'll create that, and also it will register for those consumers. Basically, there will be two set of consumers. One that will be registering for its own. Yeah.
Can I ask you a quick question?
Yes.
When you register for all topics, are you registering for all topics that exist at this moment, or are you registering for all future topics that get created?
At this time, I'm registering only for those topics. I'm not registering for future topics. So if we brought
a new adapter online, you would never get events from it?
No, I will, because the topic that are created, those are topic specific for the core. So if you have a new adapter that comes in, that new adapter will be sending information to the core, or going to broadcast it to the core. Let me go through this, and then you'll see. You understand how it works.
Okay. Yep, I did.
Okay, so the core will register for its own global broadcast for the broadcast topic and its own topic. And then at the same time, those two activities happen at the same time. The adapter does the same thing. The adapter creates a topic. They have a broadcast topic. Like, for example, if the core needs to send information to all the adapters, I don't know which scenario that will happen, but in case that happens, so there will be a broadcast topic for all adapters. There is a broadcast topic for local groups. For example, the same type of adapters, for example, an OpenOLT. You can have multiple instances of those OpenOLTs. So if I want to send an information to any OpenOLT, then I'll broadcast it on that topic. And also an adapter can also have a self topic. I put that adapter /instance ID. In this case, I put it A1. And obviously, you're going to register to that topic. Now, once the adapter does that, the first thing that they do, they send a registration message to the core. So basically, in this case, it would say, I'm sending a registration. I want to register the adapter E1. And what it does, it sends it to the topic /core, and it says, when you reply to me, because every message, every request has a response. when you reply to me on /adapters A1, like on my instance. That message goes to the vCore. The vCore will do whatever action it needs to do. And there are two different scenarios that can happen. One is a startup scenarios, I mean, everything is starting up. So basically what the vCore will do, will create that adapter in the KV store, and will say success, it will send that a reply to that adapter. And if there's any specific information that it needs to send out, it will send that out. The other scenario it would be if it's a restart, means all the system were up and running for a while, one adapter went down and came back up. So that are restart scenarios. So basically what the core will do will update the KV store with the latest information from the adapter. Chances maybe startup time, whatever. And then it will invoke a reconciliation on that adapter. Now the reconciliation itself, it's really, I believe it's a very adapter specific in the sense of maybe the adapters, if they have a peer, they will want to go and grab whatever information they need from that peer, or if they want to know what are all the devices that that adapter was supporting before that adapter type, then they can make a request into the core. So that is startup scenario. Does that answer your questions in terms of having any other adapters later on registering? I think it was Don that had that question.
Yeah, we're good. I'm fine.
Okay, so that's a startup, and I have the reason why I was not showing. How can I share this one? I'm trying to share a different drawing, but it's not allowing me to.
Ken, a quick question.
Yeah, sure.
So so right now we have cases where an adapter requires some information from the core.
Mm-hmm.
Typically it's like adapter agent call from an adapter to the core.
Mm-hmm.
So how do you see this playing out now? Would the adapter be making a Kafka call back, and that would be like an asynchronous call and then expect and reply back, or would it be a call to the KV store to get that information?
Okay, maybe then I'll show you. You'll see it in another one of those sequence diagram.
Okay.
Yeah, I'm trying to set up this size so that you can see it, but this is this is very hard to see for you folks. But basically, this is the case of a startup with multiple cores at the same time and multiple adapters at the same time, but it's follow the same logic. Like I think it will be too complex to show that one. Yeah.
I think Ken, why don't you just keep your original form and then we can zoom on our end, so you don't have to. Yeah, and then I think we can zoom on our interface.
Oh, you can?
Yeah.
Okay. But this is the scenario of we're starting all 3 cores in the cluster. This is really cluster mode. All 3 cores are starting and all the adapters are starting. They follow the exact same scenarios that I mentioned before. And the only difference what you're going to see is because all the adapters are sending the registration message on the broadcast topic, all of the cores will get the registration message. And then one of the core will act on that. Pretty much, they will try to create a data adapter, and two cores will try to create an adapter inside the KV store. One will succeed, one will fail, and the one that will succeed is the one that sent back the request. The other one will just ignore it. And that's pretty much it on that crazy looking diagram. Let me show you another case of
in a case where a call comes up after the registration has occurred and it registers for those topics, then will it just get all the things it missed? Is that how that works?
I didn't get the question.
So let's say a call 3 comes up, later, right? So registration's already occurred, and all the first 2 calls have all the notifications that the adapters register. So the third one comes along later on. So what's the process in that case? Yeah, third call, yeah.
Okay, so basically when the registration happens, the first thing that it does, it stores that information in the KV store. So whatever core does the action, you store it in the KV store, and the core itself have a watch on the store for adapters. So if you have core 2, 3, a new core comes in, it will first thing that it does, it will go to the KV store and says, oh, is there any adapters that I need to load in memory? Oh yeah, there are. It will load that in memory. So that's how it works. And if existing adapters, suppose one didn't create it, another core created, the one that was not able to do that, since they have a watch on the KV store, they will be able to detect that there's a new adapter that was created, and they are going to load it. Does that answer your question?
I think so, yeah. So basically, any data that the call that comes in later after the registration or events have occurred or whatever, it just would read all information from the KV store.
Exactly.
It's up to the core to get all that.
And the core will put the KV store.
Okay.
Okay, so let me see what I'm showing the right application. Let me show this one. Okay, so here's a case, for example, of an ONU discovery. Like the OLT send a message up, say a child device has been detected from the OLT adapter. So what it sends it to the topic core, because it's the first time it doesn't know like who's going to handle that. So it sends that message, and it says also reply to the specific adapter that is sending that. So it sends that to the Kafka adapter, and that, well, the name should not be Kafka adapter, that's the Kafka proxy, typo there. So once Kafka get that message, the proxy, it sends that to all the core. So all vCore 1, vCore 2, vCore 3 will get the message that a child device has been detected. And along with the child device detected message is the parent ID, means the OLT ID. At that point, one of the core is already managing that OLT. So the one that is actively managing the parent device is the one that is going to react to it. The other one will just make a lookup and says, oh, I am managing this parent device. No, I just ignore the request. So in this case, let's say it's a vCore 1 that is managing that parent ID. It will get that, and right away it will just say, okay, it will send a message back to the OLT adapter via the Kafka, which says, okay, I got your message. And here, as you can see, the vCore 2 and vCore 3 will just ignore the request. vCore 1 go and create the device in the KV store. And the next thing that it does, it sends an update to the Affinity router that says, okay, here is a new device and that you will need to take care of during routing. So that if there's a northbound request coming in, for example, for an ONU, so the Affinity router knows where to send it. And then the VCOL1 marks that device as being actively managed in the core. And then at that time, it's going to send the adopt device. Now this time, it's going to send it to the topic, a generic topic, the ONU adapter name, because it doesn't know which ONU adapter instance is going to take care of it. So send it to the ONU adapter broadcast topic for that specific type. And it says, when you get a response, send it back to my instance, which is the core one. So that goes to the ONU adapter. It's adopt the device. It sends back, okay, I got your message, and then it's proceed with whatever it needs to do during device discovery. Any question on that? Does that answer your question, Shad, on how they're going to communicate between the adapters and the core?
I think Shad, unfortunately, just dropped. So I'll remind him.
Okay.
And sorry for my ignorance. So when the data got pushed into KV store, the KV store actually have a response back to say, the data is being stored. I see a okay dash, that response back.
Yeah, it's not the KV store that responds back, but on the diagram I put an okay there. Basically, it's a client that we use to the KV store. It's always have a response.
Okay.
You say like, oh yeah, I send it to the KV store. But if also the KV store, if for some reason it cannot store the data, then there will be failure there, and then it will be not okay. It will be a different error message, but this is just to show that this is kind of a reply. You know the question on that? No? Okay. And another one that I can show, let me see. Well, could be. This is a case of. Which one? This is a case of a packeting. It could be for example, an IGMP request that comes in, or in your poll, whatever it is. So this is a packeting information. Again, following the same pattern. Those message get sent to all the cores. The cores that is sending it is the one that is saying, okay, I got that packet in message. It send that to the Affinity router. Like I just said, there's this mapping between the Affinity router and between the core and the OFAgent, the specific one. So by just doing a table lookup, it says, oh yeah, this packet needs to go to, in this case, OFAgent 1. OFAgent 1 send those data to owners or any other northbound controllers, get the flows back. And again, that goes to the Affinity router. The Affinity router says, oh yeah, I have this mapping. So it sends that flow to VCOL1. I believe it sent it to not just to VCOL1, it will send it to another core as well, to this primary and secondary. In this case, I'm just showing the primary one. It goes to VCOL1, which decompose the flows, and then each flows gets sent to the Kafka on different topic, one for the OLT topic and one for the ONU topic. And this goes to each one of them. You can see like on the diagram, the flows, each set goes to the OLT adapter, and the set goes to the ONU adapter, and we get the OK back. So that's a scenario of packeting.
And again, right? So the vCore send it out not just to the OF. I mean, it could be the corresponding OF agent can be 2 or 3, right? So not just like we were talking about earlier. So the pair between OFAgent and the core, they don't have to 1 to 1, 2 to 2, 3 to 3. It can be 1 to 2, something like that, right?
No, the mapping inside the Affinity router is 1 to 1.
No, right, but what I'm saying, the mapping is 1 to 1, but the vCore 1 doesn't really always map into the OFAgent 1, right? So,
yeah, exactly. It's
okay.
Yeah.
I'm just refreshed what we have earlier back there.
No, that's good. Good student.
Well, at least prove I learned something.
Just kidding.
You should see my face is blushing right now. Okay.
Okay. So that's one scenario, and this other one here is this is a case of a failure scenario. Again, we have a packet in that comes in, and it's sent to the Affinity router, and the Affinity router send it to OFAgent 1. And during that time, vCall 1 goes away. So that's dead. So what happened is the Affinity router says, oh, there's a timeout. I can't send it to the vCall 1. Okay, this is secondary vCall that I have in my in my routing table, so it automatically sends it to the secondary one, and the secondary one now mark that device as it is now actively managed, that device, because before it was passively managing the device, now it's actively managing device. Again, it does the decomposition of the flows and send those flows to the VOLTHA adapter and ONU adapter. So this way, you can, as you can see, like even if the call goes down, it doesn't matter. It's the process still keep going. Any question?
And in the case where vCall 1 comes back later on, just to follow up on the recovery scenario. So in that case, what determines when vCall 1 is ready to process any requests? I mean, is that an internal determination that, okay, now I'm ready to go? And what gates that coming back into service?
Pretty much in previous in 1.x, basically, like when a call comes up, it was assigned a specific call ID, and there could have been data associated with that call ID. So what it needed to do was it has to load all those data in memory, and once it's load all those data in memory, then it was ready to go. But in 2.0, once the call is up and it came back up, the service is up and the gRPC service is ready, and it has already registered to the Kafka, then yeah, it's ready.
So it doesn't have to complete loading data into local memory.
Exactly.
It'll do it. The Affinity router will assign it as either it'll assign it as a backup, because if the backup switches roles to primary, so it'll assign it as the backup for one of the other cores. And as the core gets requests, it'll incrementally load what it needs to from the KV store. So it doesn't need to load it all up front.
Okay. Thanks.
So the cores don't know that what their affinity is, right? They don't know about each other. They don't know about affinity. The only way that they really communicate with each other is when they're both rushing to service the same request, and one of the two locks the key in the KV store, and therefore it gets priority. But in the end, it's, the primary and backup are sort of a strange notation, but the Affinity router will always send the request to the primary first and the backup second. But if the primary is really, really, really busy, the backup will actually service the request and grab the key before the primary does.
Right. So when a call first comes up, then it's always going to be slow because it's going to have to load data. So the active guy is always going to win, I guess, in that case, right?
Yeah. Well, no, because once it's grabbed the key, for the serial number, it's the boss, whether it's loaded its data or not. So the request will just proceed a little slower for the first time for that device, and then after that it'll be just as fast as it was before.
Okay, so the grabbing the key is independent of whether it has the
whether it has
data.
to load data or not. Okay. Yeah, I think so. I mean, Ken, you can answer that, but my assumption was that grabbing the key is the first thing that happens, and then after that you go and service the request.
Yeah, that's correct. Yes.
Okay.
Hey, I have a question related to the packet in. Maybe I missed something, but look like you broadcast the packet in to every core. Does this cause any data overwhelming problem? Is there a way to reduce the broadcast to like unicast?
Yeah, well, good question. It's there are different ways of doing that. In the sense of, in order to reduce that, and here when we're talking about broadcast, here we're really talking about broadcasting to 3 vehicles. It's not a broadcast like a huge amount of data that we're talking about. It's just like really to 3 vehicles. If we want
to disrupt you, what is the word you was using? Is that a broadcast? What were the mechanism?
Oh, the mechanism. Right.
Yeah, so you see that core 1 receive a packet in, core 2 receive a packet in, and core 3 receive a packet in. For me, it's a broadcast or multicast. So
no, it is a broadcast. No, what I'm saying is not a lot of broadcasts. It's not like sending a message to 1,000 nodes. Here we have only 3 nodes that is getting the broadcast event.
Just subscribing to the
yeah.
The topic.
There's only 3. There's not a lot of them. There's only 3.
Correct, but
sense of network broadcast. It's more that I've got 3 subscribers on one topic, and they've all subscribed to it. They say, "Oh, look, I see this," and then 2 of them are like, "Well, this isn't for me anyway."
Exactly.
So it's really as fast as a Kafka client or subscriber and a topic can interact is really the question of latency. And it sounds like, given these are control packets, it's not like data plane traffic where you're trying to move 10 gigabit through this. It's what it takes for an IGMP or a DHCP or an EAP to get pushed out or back again, right?
Yeah, exactly. That's how it works. And
the only thing we need to test is how many of these you can get flooded in without causing issues, or just in the Super Bowl syndrome can cause a lot of IGMP packets to flood in through this. So we need to test and see what the limits are.
Oh, for sure. There is a lot of it will depend on the type of configuration that we want on Kafka and how many partitions we want to have.
Yeah.
But one thing that it's a balancing act in the sense of we can either go and try to reduce, and what I try to do is try to reduce the total number of topics that we're going to have. By reducing the number of topics, automatically we need to have some broadcast that will happen. One way to reduce that, even go further, reduce that number of broadcasts would be in the adapters and the core, and this would be really around the Kafka proxy. Maybe an augmentation to that would be for it to have an internal routing table, for it to know which instance of an adapter or an instance of a core that is actually handling a certain device, so they can send that request specifically on the topic for that device. Where it gets complicated is if a core or an adapter goes down, they will need to flush that cache, or at least flush it for certain devices and rebuild that slowly. So that's one way to alleviate that. The other way to do that would be literally to have a topic per device. And I shy a little bit away from that because I don't know how many devices we'll have in the system. If we have 100,000 devices, if we support 100,000 devices, we'll automatically have 200,000 topics, one for the core and one for the adapter. So that could be, Kafka may start to choke. There's no limit specified on Kafka, but once we have that number of topics that it has to manage, chances are we'll start to find latency problems. So it's really a balancing act, and maybe it's something like during testing with huge amount of data that then we are going to see which method is better. But in any case, the design of it doesn't prevent to go either way. even if we want to eventually. Does that answer your question?
Yes, sorry, I was in mute. Yes, it's a good question. Thank you. Good answer. Thank you.
Okay. I think the information here is that the Kafka install, given it's now in the middle of every bit of the IPC, it's just going to have to be fast and bulletproof and big. There's going to be a lot of file descriptors open, a lot of sensitive timing, lots of topics. So it's like etcd, it's now going to be in the heart of everything, and it's going to have to be able to handle the traffic.
Absolutely. And IGMP especially may want to prioritize that somehow.
Yeah, I don't know. Is there a way in Kafka to have like high priority topics that are more timely? I'm not sure. I've never tried.
I thought that was usually multiple Kafka instances where one's a higher priority rather than on topic, but
yeah, it's something that we could explore.
Well, I think that seems like we just found a topic to put it on the table to discuss of this, because the high priority differentiation definitely need to be supported by the VOLTHA. So IGMP alone, I think there's right now 3 service providers require that. So we definitely need to discuss this.
Do we have an idea of how much we can get away with for IGMP? What's the latency that we have to stay under?
Yeah, for sure that's defined. To look it up, it's it may be a couple hundred milliseconds, but it may be less than that.
I think we went through that. We went through that analysis during the lockdown a little bit, right?
Yeah, I thought
and we're talking about how many hubs. Yeah. Sorry, Matt.
But it may be like make sure if you do any persistent storage, it's all SSD or NVMe, and maybe make sure this guy gets higher priority, at least on the CPU. So
you get under 5 milliseconds per hop. So
I mean, I think there's tuning here that could be done to make it so. It's just something to consider.
Yeah, maybe it just works, but especially under a loaded situation, like obviously like Super Bowl channel changes, those kind of things are classic cases where you want to make sure it functions.
I thought people don't change channel when they're watching Super Bowl.
You do in commercials. Halftime, they want to go look at something else.
I think the commercial is very interesting to watch. I think that's one of the big things.
Super Bowl, but during the regular season, there's usually a few games. Especially on a Saturday, if you like college football, there's usually 4 or 5 games you want to go.
You can see I don't watch sports. Oh, okay. One thing, Ken and Sergio, and everybody else in the community, I think the scalability and capacity of this, we probably do need to, not just this use cases, and I think right now, today we touched a few times regarding to, how exactly resources intensive, when we have introduced this new framework. So Ken and Sergio, when you guys doing this development in the core, do you have any like scalability and capacity analysis available, or is planning to be done anytime before the release of 2.0?
Yeah, we need to do that before the release of 2.0. Stefan had done an analysis of earlier, right? And we're going to just repeat that same analysis with the 2.0 core.
Right, because I think one of the questions people was thinking about, what's the compute resources right now we need to be loaded up with all these VNFs, right? And then plus, the name is going to be on top of that, and then also the ONOS is combining.
Yeah, so hang on. So we're going to do the same testing we did on the core. We're not going to test with NEM and ONOS and all that other stuff, right? We're not going to test SIBA. We're going to test we're going to do the test we did with VOLTHA the previous time, which is basically writing to the VOLTHA APIs to create devices and saturating it to the point where it falls over and understanding where that is, how much CPU is being consumed, how much memory is being consumed, how much disk is being consumed by process. So we'll know how much etcd is using, how much each vCore is using, how much the proxy or the Affinity router would be using. But we're certainly not going to do an end-to-end test on a CIBA install, because first of all, I don't know that CIBA is HA yet, nor will it be HA in time, and I'm not sure how CIBA is deploying ONOS. Right? Is ONOS in its own cluster? How's it being deployed? Exactly.
I think that.
Go ahead.
Exactly. So I think on the CIBA side, we probably do need to kick off the initiative of this. Sergio, would that be possible when, I'm sure you're thinking about this now, about regarding to how you're going to test this. Do you need other people's input regarding to how, are you going to, for example, right, are you going to have some assumption regarding to how many OLT and how many POM ports and how many ONT under that? I provided a very high number to Ken before. Is that something you guys are going to use for this kind of analysis and study?
So the way we do it, Sean, is that we basically test in a very small environment, right? There's no way. You know, if I get really big VMs and I test 1 million OLTs and ONUs, it's the same thing as getting really tiny VMs and testing 100 of them instead, right? Right. Because the tiny VMs will have memory limitations. They'll be running a single core, right? You know, you run these VMs on one core, one vCore, which is basically a half of an Intel core, and you give it very little memory, and then you see how it breaks, and you make the assumption that this is linearly scalable, and one way to prove that is you go with 2 cores and double the memory and see if it linearly scales, and then you've proven your linear scalability assumption, and you say, okay, so now we understand that this scales linearly, so here's how much memory you'd need and how many cores you'd need to run this if you were handling, you know, 10,000 OLTs and all their ONUs, right? That's basically how we're going to approach.
So do you have enough the setup so you can do minimal to and then start scaling up, or do you want other lab? Yeah, do you want other lab maybe join?
Yeah, we have lab resources to do that. I mean, we did that last time, right? We can create lots and lots of VMs in our lab. And in fact, we could, if we didn't have the lab resources, just create them in AWS anyway, if we wanted. But we've got enough lab resources to do the testing that we want to get done.
Hey, Sergio, I've got a caveat for you. Can you
hear me? Yep.
So when we were doing BNG testing, if you're using the regular network drivers, i.e. they're interrupt driven, one of the things that kind of maybe a minor flaw in what you were describing was you get better performance if you have more VMs, mainly because you have more kernel threads plucking packets off of an SR-IOV interface. So just be careful of that. I mean, significantly more throughput by adding VMs versus containers. I mean, not even in the same ballpark. We could get more traffic through a bunch of VMs than we could a bunch of containers. If you go DPDK, that's a whole different story. Just understand that if you give it more kernel threads or more kernels, more Linux kernels, you will get better throughput.
Okay, so but our VMs are running like a complete, so we'll have 3 VMs, right, which will be clustered together to form the 2n+1 deployment of VOLTHA, and each one of those VMs is going to be running all its containers, and we're not going to run any extra VMs. We're only going to run those 3, right? to simulate 3 servers or 3.
Yeah, I just want to make sure you're aware of that. I'm not taking apart your test plan. I'm just saying.
No, so yeah, I get it. So
you could, if you tried to run a router on a single piece of hardware, and then instead ran a distributed router across 10 VMs on the same exact hardware, you would get way more throughput. Just because you have more threads plucking packets off of the network interface.
This is in the 40 gigabit.
That's something to be aware of.
But this is when we're running it. Data plane 40 gigabit plus.
Yeah.
Yeah.
Well, even on a small packets, it was hard to get line rate without adding more and more VMs. So,
okay, I understand. I think with the size of VMs we're using, networking really isn't one of the bottlenecks, to tell you the truth.
Agree.
Yeah. Okay.
But adding VMs will mask it if it is.
Okay. Understood.
And just a time check, we've got about 2 minutes left.
Right. So this is what I'm going to say. So Sergio, I checked the HA deck I have doesn't have the alternative routing portion of that.
No, it doesn't.
So
I agree. It doesn't. I just updated it. Do you want me to send it out or?
You can send it out to or post on the wiki. I think including all the flows. I think we need to make available to other people too. So.
Yep.
I'll work it out with you offline. I think this is a very wonderful discussion today. I think it's very worthwhile. Julie, back to you.
Okay, so I'll go ahead and take presentation right back. And I think with that, we are done for the day. I'm trying to share my screen here. So thank you everyone for the discussion. We do have on target next week a discussion on the code that's there for VOL 506 to do a walkthrough of that with the developers. And then in the future, we also wanted to have a deeper discussion on multicast, and that one's still to be scheduled. I think that's it for today. Any last comments before we close today's session? All right, let me stop the recording.